Welcome to Study Loop.
So in this problem, we are given with the decomposition reaction of NH4SH, from where we are getting ammonia and hydrogen sulfide gas. We are given the value of Kc for the equilibrium um, achieved in this reaction, and we have to find out the equilibrium concentration of each of the products, which are NH3 and H2S. So to do that, first you have to set up an ice table for this reaction. So if we set up the ice table, the reaction is NH4SH, which is a solid, decomposing to give us NH3 and H2S. Both are gas. So for the ice table, we don't know the initial concentration of um, the solid reactant, but we don't need that because in the equilibrium constant expression we do not include pure solids and pure liquids, as we consider their concentration as unit. um, that's why we assume that their concentration does not change over the reaction, and that's why we just need to know the concentrations of the products which are gaseous here. So these products will be included in the equilibrium constant. So the initial concentration of both the products will be zero, since at the initial state there is no product being formed. Then in the change here, if we assume the change in the concentration of the NH4SH is X, that means the change in the concentration for both the products will be plus X. And from there, if we write down their equilibrium concentration, it will be, for both of the products, it will be X. That means now if we write down the expression for the equilibrium constant Kc, this will be only the product of the concentrations of product. So that will be the concentration of NH3 and the concentration of H2S. Now both of their concentration from the equilibrium constants are X. We'll write both of them as X. And the equilibrium constant Kc is given as 1.2 times 10 to the power minus 4. Now from here, that means x square is equal to 1.2 times 10 to the power minus 4, and that means x will be the square root of this, which will give us a value of 0.011 molar. So this is the equilibrium concentration for both of the product, that means NH3 and H2O. For both of them, the equilibrium concentration is 0.011 molar.